Yes, I am audible to you.
Yes, sir.
Yes, Asik. Let me start. Basic introduce yourself.
Good afternoon, sir. Myself Abhishek Gupta. I'm from Gangapur City, Rajasthan. I've completed my foundation education from my hometown, Gangapur City. After that, I pursued BSc in Chemistry Honors from Maharaja College, Jaipur, University of Rajasthan. Subsequently, I got selected for the IIT-JEM examination with an all India rank of 290, which gets me into the IIT Gandhinagar for MSc in Chemistry. During my master's stage, I was fortunate enough to taken part in two research projects. The first one includes the hydrolysis of urea into ammonia with the help of an immobilized urea enzyme, and second one involves the synthesis of small therapeutic molecules for the treatment of neurodegenerative diseases like Alzheimer's and Parkinson's. During both these research projects, I have explored many analytical techniques like UV, IR, NMR, DLS, SEM, TEM, etc. And they also sparkle my interest toward analytical chemistry and data analysis and research aspects of the chemistry. Apart from these, I have also excelled in national level highly competitive exams like CSI, NET, and GATE. I achieved All India rank 46 in the CSI NET JRF and All India rank 468 in the GATE examination. And I believe and confident that my research experience coupled with my academic skills can be proven a valuable asset to the research and development initiatives that are happening at this organization.
Yes, good, Abhishek. Yes, your name is Abhishek. What the meaning of your name? Describe.
Sir, Abhishek is from the Sanskrit. Its basic meaning is the blessing, and it's also related to the ritual in the ancient times, where when a new king taken over the kingdom, then the holy water is placed on his head, and that process is called the Rajabhishek. Uh,
Yes, good. Next is what's your strength and weakness? Describe.
So my strength is that I'm a disciplined, reliable, and punctual person, and you can rely on me on my tasks. I will try to give my 100% on my work. And talking about my weaknesses, I am more into the process. Like I'm more of a conventional person, so, about taking shortcuts. But sometimes shortcuts are also beneficial, and I will try to rectify that by being more flexible.
Yes, good. Next one is your HR section. You have a lot of exams qualified, IIT JAM, CSIR, and GATE. What the main purpose of these exams is in our education system, India? Explain.
So these are the major exams in the chemistry field to check your academic skills. They also check your decision-making power in the precious situations and how to keep you calm and how to be, and you can crack them and achieve good rank if you are quite disciplined and consistent in the field. And they also test basic concepts of the your chemistry knowledge.
Yes, good. Next, move on your hobby. Yes, your hobby is playing cricket, listening music, and other one watching movie. Yes, can you describe how to use your hobby in a day, week, month? How to manage them?
So wherever I'm free, I used to watch movies and listen music and watching and sometimes playing cricket. So cricket, being a sports, give me the value of the dedication, teamwork, and hunger to achieve something. Music just helped me to recharge and refresh my mind if I got overworked sometimes. And movies give me a different cultural aspect of different countries and help me to improve my visualization and imagination.
Yes, good. Next one is cricket. Yes. What the main history about cricket? How do you feel?
So cricket is a game that is started nearly about 1870, and it's quite popular in India, and it's the most loved sports of the India. Uh, it's played in the majorly in the Australia, England, India, Pakistan, South Africa, Bangladesh, and it's quite advancing. Like introduction of IPL in the cricket gives it a new economical boom, and it also contribute to our country's economy. Like ICC events and World Cups happening, so there are so many tourism, hotel business linked to cricket.
Yes, good. Next, move on your native place. Here, your district is Gangapur city, Rajasthan. Yes. How do you feel about your district? Explain. What the
Uh,
of your
Sir,
Rajasthan?
in my district, there is the Ranthambore National Tiger Sanctuary, which is the most popular place here, and it's quite popular internationally due to presence of the tigers in the wildlife sanctuary. And like it all depend on the tourism economy, but there is no any more heritage sites, or only Ranthambore Fort and wildlife sanctuary.
Yes. What's your favorite place in your district?
Uh, so Ranthambore Wildlife Sanctuary, that's my favorite
Yes.
place.
What the role of your district in Rajasthan? Political, economical, geographical, cultural.
So geographically, it had the Ranthambore Fort, which has a quite good importance in the Rajasthan history, ruled by the Rajput ruler Hamir Chauhan, and it has a quite much massive history. Economically, saying that it contributes to our tourism economy, and politically, we have our MP and MLAs from here. And nothing much else.
Yes, good. Next, move on Rajasthan. Yes. How do you feel about Rajasthan state in our country, India? What the history? Can you describe?
Yeah. So Rajasthan, but talking geographically, Rajasthan is the biggest state of the India. It gives India a new dimension that includes the Thar Desert. And Rajasthan is also famous for its tourism, so contributing to the economy of the nation. So many tourists visited our state during every year. Like in the Jaipur, there are you can see so many foreign tourists wandering here and there. And Rajasthan history is also rich. We are so proud of that. Especially the Rajput rulers that ruled here. The bravery of those rulers are in our soil, and it's quite fascinating and being the prime movement for all our state natives.
Yes, good. Next is what the main major role of Rajasthan in our country, India.
So major role of Rajasthan, I think it contributed majorly in the tourism economy of the Rajasthan. Like every foreigner or even Indians who want to visit Rajasthan once in their lifetimes. So it is that, and also it's a handicraft and folk artists are also famous. Like some folk singers are there.
Yes, good. Yeah, next move on. I think your chemistry section is left. Next move on first is chemistry. Chemistry is spectroscopy. Yes. What the main application of spectroscopy in chemistry?
So spectroscopy has given the new aspect of chemistry. It breaks down the conventional concepts that's being followed. Like in the ancient times, in the chemistry, we only followed preliminary tests like color, flames, or order. But spectroscopy gives us a confirmatory test, like which can be present. Uh, so it gives us the confidence that yes, this molecule is that. So majorly a characterization technique.
Yes. Yes. What the basic difference between spectroscopy and spectrometry?
So spectroscopy includes the interaction of light with the matter, and the matter got excited, and we got its knowledge about the a transition that happened between ground and excited state. In the spectrometry, there is a we put an X-ray or something on the molecule, and it got fragmented into different compounds. So we separated it via the mass or charge ratio.
Yes, good. Next move on. UV visible spectroscopy. What the main application of UV visible spectroscopy in spectroscopy?
UV visual spectroscopy used to excite electrons from its ground excited state. So if we want to characterize a sample, then we put the sample in the UV spectrometer and it excited sample. And then you can check its absorbance and relate it to its concentration. So it's a quantitative analysis technique.
Yes, good. What the source of UV and visible?
So deuterium lamp and hollow cathode lamp are the source.
First is Lambert law. What the main application of Lambert law in UV visible?
Lambert law is the basic law of the UV. It relates that the absorbance of a sample is directly related to the concentration and the length of the container used. And it also gives us a relation that absorbance is equal to epsilon into C into L. And epsilon is the molar extinction coefficient, and C is the concentration, and L is the length of the UV used.
Yes, good. What the limitation of Lambert law?
So limitations are that it doesn't apply to the concentrated solution. If we're using more concentrated solution, then it becomes constant, like it do not follow the equation. Also, if there is some disturbance in the monochromator, then it won't follow.
Yes, good. Next is what the difference between chromophore and oxychrome in UV? What the example?
So chromophore and oxychrome are the groups that puts molecule in the UV range. Like if we align a ketone group and alkene group to the molecule, then its length got increased and energy decreased. That leads to the bathochromic shift in the molecule, and it puts it in the UV range. So chromophores are necessary for UV detection, and oxychromes are the molecule that attach to them so that some amount change. So both the groups change the wavelength or energy transition of the compound so that it can be come into the UV range.
Yes. Next is what is UV spectrum and shift in absorption band, and how many types of shift present in UV?
So two types of band allowed and forbidden transitions are in the UV band. Like if absorbance is up to 10 to the power 2, then it's allowed, and it's less than 10 to the power 2, then it's a forbidden transition.
Yes, good. Next one is what the basic difference between red shift, blue shift, hypsochromic, bathochromic shift?
Talking about the wavelength, then there is the red shift and blue shift. If the wavelength got increased, then it's called red shift. It also called the bathochromic shift. And if wavelength got decreased, then it's called the blue shift, and it's also called the hypsochromic shift. And talking about the absorbance, if absorbance got increased, then it's hyperchromic, and if absorbance got decreased, then it's hypochromic.
Yes, good. Next is what the main uses of UV visible spectroscopy in UV and so in our society and human life, daily life.
So UV visual spectroscopy leads us to the characterization. We can characterize molecule on basis of this. It gives us the dissociation energy of the molecule, excite molecule in the higher excited state, so that if we want to put any reaction, it's excited state, then it's possible. Talking about the fertilizer context, that ammonia can also be quantized by this method. If we use the phenate or Barcelona method, then we convert it into the endophenol dye and then measure the absorbance, and absorbance will give us the concentration of the ammonia used.
Yes, good. And one question in left in UV is what the main application of Woodward-Fisher rule? What the main uses in UV?
Woodward-Fisher rule help us to theoretically enable that any molecule will fall into which lambda max. So by using its rule, it shows that some residue added can add to the wavelength measure. So theoretically, we can calculate our lambda max for the certain molecule by this law.
Yes, good. Basic. Next, move on infrared spectroscopy. What the main application of infrared in spectroscopy?
Infrared spectroscopy tells about the bond strength of a molecule. It also gives us the dissociation energy, and it is given by the molecule containing the dynamic dipole moment it also a characterization technique in it we draw the transmittance versus wave number graph, and for different functional groups, it has different shift or peak values.
What is the source of IR? Near IR, far IR?
IR source is the blower source, and nurse blower are the major sources of IR.
Yes. Next is what is molecular vibration in IR? And how many types and what the uses in IR?
Molecules are not solid rigid molecule. They behave like a spring, so they vibrate continuously in the molecule. And vibrations are like symmetric, asymmetric stretching, and also there are bending vibrations. So two types of stretching and four types of bending vibrations.
Yes, good. Bending vibration. Number of fundamental bands. What is fundamental bands in IR and how many types?
Fundamental bend occurred when a transition occurred from the most intense populated ground state to any other excited state. And it is also the most intense transition of our whole molecule.
Fundamental band, first overtone, second overtone, and hot band. What are the differences?
So when transition occurs from ground state to first excited state, then it's called fundamental band. And it occurs from ground state to the second excited state, then it's called the overtone. And it occurs from the first excited state to second or third, then it's called the hot band.
Yes, good. Next is what the basic difference between vibrational degree of freedom, rotational degree of freedom, and transition degree of freedom? What the formula in UV?
A molecule that put in a 3D space has different type of degree of freedoms that represent its motion of the molecule in the free space. Like for the translational, it depicts its motion in the XY plane or 2D motion. Rotation, it can rotate in three ways, and also vibrational, there are three ways, and all of them contribute to the internal energy by their own means. And it's different for the linear and non-linear molecules, depend on the structure too.
What the formula of vibrational degree of freedom in transition state?
So vibrational degree of freedom contribute to KT at the room temperature or higher temperatures, and it contributes 0 at the low temperatures. Translational degree of freedom contribute to 1 by 2 KT, and rotational is also 1 by 2 KT.
Yes, what the formula of vibrational degree of freedom for linear and non-linear molecule? And what the example?
For linear molecule, there are like if n atoms are present in the molecule, then 3n minus 5 and 3n minus 6 for linear and non-linear respectively.
Yes, good. Next is what the formula of vibration frequency?
So vibration frequency nu is equals to 1.2 pi root k by mu, where k is the force constant and mu is the reduced mass.
Yes, what is 0 point energy? What the role of 0 point energy in IR?
0 point energy is the energy that molecule always possesses before going into an excited state or ground state. Like if we put n equals to 0 into the energy that is n plus 1 by 2 h nu, then we can get the 0 point energy is 1 by 2 h nu.
Yes, good. Next is what is coupled vibration?
So coupled vibrations are those when two vibrations are occurring in a single molecule or different molecule, and they have the similar wave frequency number. Then they couple to give a new higher intense and a lower intense vibration. That's called a coupled vibration, and it also called resonance.
Next is Fermi resonance. What is Fermi resonance?
Fermi resonance. Yes. Fermi resonance is also same. If a combination band or a overtone got the same frequency, then they got mixed and produced two different bands, and that's called the Fermi resonance.
Yes, any drawback limitation of IR spectroscopy?
Sir, IR is not applied to the molecules that do not have dipole moments like H2, N2, or O2. And also we can't totally depend on the IR for the confirmatory test.
Yes, good. Yes, you talk about the rotation spectra. What is rotation spectra? Microwave.
Rotational spectra is the energy occurred when we put a microwave radiation on the molecule, and due to its rotation, it aligns with it. So it gives us the basically the bond strength or internuclear tells about the internuclear distance of the molecules.
Yes. What the basic difference? Microwave active and inactive molecule. What the example?
So basically, they are dependent on the dipole moments. If a molecule have permanent dipole moment, then it's microwave active. Otherwise, it's microwave inactive. Like CO2 molecule is microwave inactive, but HCl molecule is microwave active because of the dipole moment presence.
Yes. What the selection rule of rotation spectra?
Selection rule of rotation spectra is delta G equals to 0 plus minus 1.
Yes. What is your polyatomic molecule in rotation spectra? And how many type?
Sorry, sir, I'm not getting.
Polyatomic is a linear, symmetric top, asymmetric top, spherical top.
Okay.
These are the
So there are
part
three
of-
types of top. Yeah. So spherical tops are the tetrahedral, octahedral, or highly symmetrical molecules. Then there come the asymmetric tops like H2, which contain maximum C2 axis. And there are symmetric tops, which are two types, prolate and oblate, and they contain more than C3 axis symmetry in them, like NS3.
Yes. Good. Any drawback limitation of microwave rotation spectra?
Firstly, apply on the molecule which have the only dipole moments.
Yes.
So it will basically range out the many molecules, so we can't characterize this on basis of this only. And microwave coupled with IR is a good, considered good. Alone microwave is not a good relative.
Yes, good. Next, move on NMR spectroscopy. What the main application of NMR? What the source of NMR?
Source of NMR are the radio waves, and it's nuclear magnetic resonance. It is the highly characterization technique used in organic synthesis. It is of different types, like 1S, 13C, 19F. So those molecules which have nuclear intensive I value not equals to 0 are NMR active. With their application in the organic synthesis.
Yes, good. Next is what the basic difference NMR active and inactive molecule. What the example?
Sir, NMR active molecules, those which contain the I nuclear spin number not equals to 0, like 1H is an NMR active, but 2H is not NMR active. Like same 13C molecules are NMR active, but 14C is not. So it depends on the nuclear spin number.
What is chemical shift?
Chemical shift is the data is the value of the data that if molecule will absorb depending on the certain environment around it.
What is Pascal triangle? What the main application of Pascal triangle in NMR?
Pascal triangle is a mathematical technique which gives us a symmetric calculation method like 0, 1, 1, 1, 2, 1, 1, 3, 3, 1. And in the NMR, the NMR lines are split into this Pascal rule, like n plus 1 rule. So if there are two hydrogens splitting, then they split it into plate 1 is to 2 is to 1, and three hydrogens there, then it will quartet 1 is to 3 is to 3 is to 1. So we can predict our splitting according to the Pascal triangle.
Yes, good. Any drawback limitation of NMR?
NMR, like it's sample, like firstly the instrument itself is quite costly and will require highly maintenance. And it is not applying on the nucleus with zero atomic numbers, like we can't distinguish them. Otherwise, it's a good technique of calculation, majorly commonly used in the organic field.
Yes, good. One question left in NMR. What the basic difference between 1H NMR, carbon 13 NMR, 19F NMR, 31 phosphorus NMR? What are the differences?
So in 1H NMR, we can calculate the number of hydrogens, different number of equivalent and non-equivalent hydrogen present in the molecule. In the 13C NMR, we calculate the 13C numbers, but in 13C, since the Garrett-Mantin ratio is low and also its natural abundance is low, so we need a more amount of sample in 13C to detect our molecules. Similarly, in the 19F, we put the light rays on the 9F fluorine molecules, they got excited and give us the values.
Yes, good. Next, move on ESR. ESR and EPR spectroscopy. Yes, what the main application of these one?
So electron spin resonance. The main application is that we can detect any unpaired electrons. Like it has the simple selection rule that molecules should contain unpaired electrons, and the basic principle is same as the NMR in terms of the electron.
Yes, what the selection rule of ESR, EPR?
Selection rule for ESR is that there should have an unpaired electron, and like delta MS is not equals to 0.
Not MI is equal to 0. MS plus 1 is 1.
Delta MS is equals to
What is hyperfine splitting?
hyperfine splitting is the splitting due to the unpaired electrons present in the molecule. Like 2ni plus 1 into number of unpaired electrons, then it will give us the value of hyperfine splitting values.
Yes. Next one is Mossbeer spectroscopy. What the main application of Mossbeer?
So Mossbeer spectroscopy is for the characterization of the nucleuses, like iron or tungsten. In this, we use the cobalt source, like we excite the cobalt molecule and then use its wavelength to put on the iron source. And on the basis of density of D and S electrons present in the sample, we can characterize our nucleuses.
What the source of Mossbeer?
So cobalt, like we excite it to the higher state, and when it comes back, then we put that radiation into our sample.
Any drawback limitation of Mossbeer spectroscopy?
Sorry, sir, I'm remembering it.
Next, move on mass spectrometry. What is mass spectrometry?
Mass spectrometry is a quantitative analysis technique in which quantitative and qualitative both, in which we use the X-rays to excite a molecule and remove the fracture and use the fragments and separate them on the basis of the mass or charge ratio.
What the basic difference between molecular ion peak, base peak, parental ion peak? What the difference in Mass.
Molecular ion peak is the peak of the molecule. Like if the weight of the molecule is 160, then 160 is the molecular ion peak. And base peak is the most intense peak that comes in the mass spectra. Like which fragment is more in the spectra, then base peak of that is highest. And parent peak is the peak of the molecule before fragmenting.
Yes, buddy, elemental analysis in mass.
Elemental analysis is that we want to quantify that how much amount of element is present, so we can check it into our mass.
What the ratio of detection of chlorine, bromine, iodine in mass in elemental analysis in mass?
For the chlorine is present in abundance of 1:3, and the bromine is the 1:1. So by using that ratio, we can calculate.
Yes, good. Next, move on physical spectra. Electronic spectroscopy. What is physical spectroscopy? And how many types?
Physical spectroscopy is the basic of all the spectroscopy techniques, and it relies on the three concepts like the selection rule, population ratio, and selection rule and population ratio. So every spectroscopy has its own selection rule, population ratio. It governs us with the theoretical rules that how basic principles of the spectroscopy techniques.
Yes, molecular spectra is rotational, vibrational, and electronic plus Raman. Yes, what the difference of these one? Basic.
So they have difference in the their selection rules. Like for the vibrational spectroscopy, there should be a dynamic dipole moment. For rotational, there should be a permanent dipole moment. And electron spectroscopy is available to all. And same is the case for Raman. Like mostly molecules are Raman active.
Yes, mostly we have discussed in earlier spectroscopy. What is PQR branch in rotational spectra? Rotational vibration.
PQR branch in the rotational vibration spectra is that if a molecule goes from the J equals to 0 to J equals 1, then it will create a P branch. And if it comes from 1 to 0, then it will create a R branch. And it's from 0 to 0 transition where that will create a Q branch.
What the application of Raman spectra?
Raman spectra is a physical spectroscopy technique which relies on the scattering of the molecules. And it also helps us to characterize the molecule, like a Raman active molecule can be characterized by this.
Yes. Next is what the basic difference is Stokes and anti-Stokes and relay line.
So in Raman spectra, we put an radiation on molecule and then it got scattered. Sometimes the intensity of the scattering line is more than the incident one. If the intensity is more, then it's called the anti-Stokes line, and intensity is less, then it's called the Stokes line.
Next one is what the basic difference between Raman and IR.
Raman and IR. So Raman is a scattering technique, like it relies on the scattering of the radiations, and IR is the absorption technique.
Yes.
And IR is a spectroscopic technique. Raman is not purely spectroscopic.
Next is what the difference between Raman and fluorescence.
Raman and fluorescence. So in fluorescence, the molecule got excited to high level and then emit energy if it coming to singlet to singlet. And the Raman scheme, there is scattering. So fluorescence is also an absorption and emission spectroscopy, and Raman is a scattering.
And Raman and phosphorus?
Phosphorus is also an emission, but it's a slow and time-taking process, also not a spin out. So it has a low, very low intensity compared to the fluorescence or Raman.
Yes, next one is electronic spectra.
Electron spectra based on the Frank quantum principle, and it states that a molecule, when got excited, do not have enough time to change its internuclear state.
Yes, next is Frank quantum principle in electronic spectra, the main application.
It states that when a molecule got excited to higher level, then it occurs so rapidly that it does not change its internuclear stance.
Yes, good. Yes, spectroscopy is overall is completed. You have a lot of knowledge in your spectroscopy. Yes. Suppose if you will be
Yes,
selected in NFL as a MTCL chemistry officer post, so how will you contribute your knowledge, spectroscopy knowledge in your department, chemist? Describe 5-10 points.
Spectroscopy is a vital technique in any industry. Like if anyone is making industrial chemical products, then we need to characterize it that our certain functional group or the quantity that we want to make is there. So we can use like AES also for the trace metal analysis if there are impurities are there. We can use it in quality control, like especially to the urea, it contains the amide group, so we can use the FTIR for that. Also, it's mass spectrometry.
Yes, good. Next one is why you want to join NFL as a MTCL post chemist?
So I want to join the NFL because of many reasons. The first one includes that I want a good job, and this job at NFL is aligning to my career aspirations. The second one involves this is the core field of the chemistry, and I'm working in this field from last 6 to 7 years. So I just want to apply my theoretical or some research experience into this. And last but not the least, it is related to the agriculture economy, which is the backbone of the Indian economy. So if I by any means can contribute to the economy by along with my job, then it will be great.
Yes, good. What the role of chemist in NFL? Major role.
I think based on my reading and understanding, I think the major role of the chemist in the NFL is to take care of the quality control and research and development initiatives, collaborate with other departments, and also to take care of safety measurements and remove all the toxicity or control air and water pollution that can occur, and also sometimes to optimize and design the process.
Yes, good. Next one is suppose if you will be selected in NFL as a MTCL post in chemist officer. So how do you see yourself after 10 to 15 years in your department, and how will you change your department?
So after 10 to 15 years, certainly I will promote it to a higher position. And during this year of time, I think I will learn more about this industry, that how it works and what is the good for this. Being a chemical perspective, I think we can uh, uh, change some systematic pictures in the lab and introduce new technologies, and we can run programs to make updated our employees about this, and we can also make other joint ventures with the institutes like IITs or ISRs or other research institutes. So we can start like that.
Your next last one question: what the major responsibility of chemist in NFL post? What are the major responsibilities?
So with the responsibility is taken care of the chemical composition of the product, that there should not be any harmful content that can go into the crop and ultimately to the local people. and also to taken care of air and water pollution that can cause, and help to measure the safety and quality control and assurance should be there.
Yes, good. Overall, your performance is good, and we confident, and all the best for your final interview.
Sir,
Yes, sir.
is this interview like pen paper based or only they are asking verbal?
Verbal.